Okay, so today we are going to continue with the third time already discussing the SPM paper. So first time we did was the what? Oh my god, my phone. Here. Okay. So the first
Yeah.
time was actually doing question 1 to 3, and then the next one is using from 4 to 5, and then now today is 6 to 7. Okay,
Okay.
so I share first. Uh, okay, so this is the question. This one you can see.
Yeah.
Okay, so what we are going to do here now is we have to analyze vectors basically. So now you see this question, right? Vectors question, right? One of the things you must do first is always label the diagram. So you see, right, the information here. OA is 4A, AX is B, 3BX is equal to BA, and OY is 4 over 3 OA. So make sure you utilize all this info one shot. That is vectors question basically. You have to utilize all this info. So you see OA, right? So you label OA, right? So
Yeah.
here is 4A. Okay. So 4A, and then AX is B. So you start the question like this. Don't straight away look at the question like see express straight away. Don't start here. Start with the diagram. This one you cannot do anything yet because from here only you can answer these questions. So after you proceed with the basic info already, then only the ratio part, you do it in the process of solving the question 1 and 2. So this is
Okay.
how we do the question lah. So now let me think. I think I start with a basic intro on vectors first. Then we come to this question. Be easier for you because here I got my solution already here, so you can understand from here lah. Later I'll show you. Easier. We learn straight away from here. Eh? One more person. Oh, Ishan. Okay, just nice. I think you will use the what chat box. So I
Yeah.
need the phone there. Using chat box, right? Okay. So we didn't start anything yet. So we're going to do this question here. So before we do this, I will brief you on vectors a bit lah. So before we go to the question, like last time we did the first 3 questions. So I'll start a bit on vectors first. Okay, so talk first. Okay. So go to the board. Okay, so vector 5, chapter 8, form 4. I think anyone who study physics here, right, you will know this chapter very well, I guess. I think, what was you study physics?
Nope.
I think Ishan study, right? Ishan will study. Yeah. So vectors, right? You heard before in physics, right? You got a thing called vector quantity, right? I think you have heard of this before. Vector quantity. I think so. Ishan, you know about it? This one always cannot answer because you won't know this one.
Yeah.
Not really. They explain a bit. Okay. So what vector quantity is going to bring out the concept in this chapter lah. So vector quantity is your chapter 1 form 4 physics. So what it said is actually vector quantity is a quantity that has magnitude and direction. Does this give you any clue? Got vector quantity and scalar quantity. Got 2 types. Your basic of physics. Scalar quantity is magnitude only. Magnitude. But what's the difference here is the direction part. Vector got direction. That's why you see in the question, they go many areas, right? The diagram. They can point up, point right, point down, point left, right? So all that is vector, direction. So let's say I give you an example. For Ishan, this one. So like this, I got a force up here like this. And then I got a force here down like this. So if I say I assume upward force is positive, right? So the downward force will be positive or negative when you go down.
Negative.
Yeah. So that's the thing you learned in physics last time. Right is positive, right? Left is negative. So left and down is negative. So this is what vector is going to bring you. Vector here, they use the symbol I. When something goes, not I. Up or down is J. J or negative J. That's why they got a negative something like negative 3A is a vector, right? Then they have a positive vector like 3A. A is like a vector. But when it goes right, you will use the symbol I. If left means it's negative I. So this is what they are trying to say. So it can be like 2I, negative 2I. Okay? All else can understand?
Okay, understand.
Yeah. So this is what you are playing on actually. And let me think. Vector you can usually write in this form also. You've seen like this before. The bracket IJ. I think in translation you have this right in maths. 3, 7 like this. They ask you to do translation of 3, 7 like that. Means you go 3 units to the right, 3 units to right, and 7 units upward. So that's why they put a positive value. Here, positive 3, positive 7. Means you move 3 units to the right, then you move 7 units upward. But then if I switch this, right, I put, let's say, negative 3, negative 7. Means you 3 units to the left and 7 units downward. Does this recall your maths? Remember translation?
Yes.
So that one is also a type of vector actually. When you're moving different directions, right, it's already called vector. That's why the name of this chapter is vectors. So this is what it's trying to bring out. And then the other things is you need to master how you can combine two vectors to form a single vector. Let's say like AO plus OB. What you get in the end? AO and OB.
AOB.
No, you don't do like that. Usually in vectors, right, when you see something common at the left and right here, like you cut off, means you get AB. So this is how we combine vectors. I give you another one. Let's say AC plus CD plus DE. What do you get?
ADE.
No, not AD. You must straight. AC plus CD, you get AD, right?
Mm-hmm.
And then plus DE means you get AE only in the end. It's an extra step, add on. Means you can combine actually more than 2 vectors. Doesn't mean only 2. But the basic
When
one.
can snap picture and send?
Huh?
Snap picture and send.
What you said?
Can snap picture and send.
Yeah, sure. Of course, I'll send. So yeah, that's how we do. So basically, what we think is usually 2 vectors. That's the most simple thing. But sometimes the question will require you to form like this complex one so that you can reach your target point, your end destination. So this is how it goes. Like a maze, something like a maze, how you choose your route to solve the question. Okay. So this is the basic thing. And then I'll tell a bit about the formulas and stuff. Got few formulas only this chapter. So not bad. So always remember these 4 directions, very important one, that you can answer all the questions. Vectors questions are always very typical. You can notice the pattern when you do a lot of exercise. They'll ask you like in certain way only. And also you need to be good in your simultaneous, because the end of the last question, they'll always ask you find the value of H and K like that. So that one requires simultaneous concept. So there's 2 things you need to combine in this chapter. So let's say I assume right AB is A. And then I said that so what is the negative vector of AB? negative vector. Means if I assume AB is A, means negative
Even
means,
before you erase the whiteboard, you take picture.
huh?
Before you erase the whiteboard, you take picture, right?
Yeah, I told.
Okay, okay.
So that one, if I say AB is A, right, then negative vector of AB is what?
Negative AB.
No, AB equals A, not the vector itself. Means negative of
Negative
AB is
A.
what? Yeah, negative A, correct. Means I can just illustrate for you. Let's say I have a point A here, then a point B here. Let's say something like this. So if I go this way, it means it's vector AB. Huh? So I said this, assume this is A. So based on this. So if you go opposite direction, right, this is what I call negative AB. And negative AB is also same as BA. So they can call it two ways. So you see the direction of B to A, that's why it's labeled BA. Or you negative AB, means you negative this value over here. So you get negative A. As like I showed you earlier, to the left is negative, right? When you go to the right, it's positive. Huh? Okay? Yeah. So that's the thing. And then zero vector we label like this. Zero vector is just basically zero. Yeah, looks like this. Zero, and then you put a sign like that, a wavy sign at the bottom. Okay. And then this is the first formula, a proper formula that you have to memorize now. Magnitude. So how it goes is the symbol is like this. This symbol. So when you're writing in your exam, right, you're working, you must write like this to represent magnitude. Means like modulus, but it's not actually a modulus. So you put a modulus like that, then R, and then a wavy sign at the bottom. Okay, so it's like that. And the formula is like this. Square root, remember square root, huh? Square root x square plus y square. So this is the formula. So it's like basically like your Pythagoras theorem stuff, isn't it? Like c square is a square plus b square. Then you square root the whole thing. So that's a clue for you to memorize this formula. Thing of Pythagoras theorem. Okay, so the form is like that. If got negative also, you can sub in. Let's say I got, I give an example. CB is 8I minus 6J. Means what is your magnitude from here? What will you sub in your x?
8.
Yeah, very good. 8 square, remember square. Huh? And then y?
6 square.
Yeah, but safer just put negative 6, negative 6 square. You still get the same thing, but just for working sake, put the negative sign, because I say 8I minus 6J. So you take the whole value. So finally, you will get square root 100. So your answer is 10 units. Huh? This is like your Pythagoras theorem, right? 8, 6, then the longest side will be 10. So this is what they're trying to say here. Okay. So that's one thing. And then one more special question is also unit vector. So unit vector, the formula is like this. The symbol you must memorize also, like this. R and then a head on top of it and a wavy sign at the bottom. Magnitude is only wavy sign at the bottom. This one got head on top. So the formula is xi plus yj over square root x square plus y square. Looks complicated, right? But actually it's not that complicated. So if you see 8i plus yj, right, isn't it the same as what I gave you on top here? 8i minus 6j. So this one you can put it inside here. So that is your xi plus yj. X and y is like constant. Means like the x is 8, y is negative 6. So this is what they are trying to show. The one with the wavy sign is always representing vector. That's why I got I and then the wavy sign, j and wavy sign. Okay. And then I divide this thing, right? X square root x square plus y square. What is that?
Substitute 8 inside. Substitute the number inside.
Yeah, we already got here, but what these 10 units represent what? What quantity?
The vector.
On top here.
Oh, magnitude.
Yeah, magnitude. So what we are doing is actually
Scale vector.
Huh?
Nothing there. Say wrong version.
So this one is basically the vector over magnitude. Look, that's how you memorize the formula. It's a vector over magnitude. That's why they put that square root x square plus y square. Means the value you get on top here, 10, you sub inside here. So that's how the formula comes from.
Mhm.
Yeah, so that's the one. And then there's another one, xi plus yj. You get x, y, and then I like this. So let me think how it goes. Okay, so this one, x will be your I basically. Y is your j. That's why they write it like this. Just now I showed you one translation 3-7. So your x is I, y is j. So x and y can be numbers any numbers you like. Okay. And then one more thing, multiplication of vector. So this one is a normal algebraic multiply. Let's say I take k times vector a, what will you get?
K times
A, the vector sign. Let's say like I put
Times
2
what?
times x, something like that. What will you get?
2x square.
2 times x only.
2 times x only. 2x.
Yeah, correct.
Mhm.
So this one you apply here. K times vector A, you will get KA.
Ka.
But just the A, right? You put the wavy sign at the bottom to show it's vector.
The
That's all.
K?
Huh?
The K didn't
It's
put
like
it.
a constant.
Oh.
Any number you like. That's why they use alphabet to represent a constant. Usually like that. Or they can use like alpha, beta, all that. You'll see in your quadratic. That one. So that's it. Now, Simpson addition and subtraction. This is what we will apply in the question. This one all we rarely apply, I would say, but can come out.
Mhm.
The basic thing that makes you combine everything is addition and subtraction. So let's say I give an example, a simple one only. 2ab plus 3ab, what will you get?
5ab.
Yeah, very good. So this is how you combine vectors. No? Let's say I give you a more relatable example. Let's say 2x plus 3x plus 2y. What is your final one?
5x 2y.
Yeah, correct. 5x plus 2y.
Mm.
So this is how we combine vectors. This all can represent vectors like this AB plus BC plus CD. So what you get here in the end is actually AD. Because B and B same, right? You cut off. C and C, right? The same cut off. Then A at the front, D at the back. Combined. AD.
Oh.
So it's just like a pattern, something like that. And then subtraction also same thing. This one is addition. So subtraction, let's see. 4a minus a, what will you get?
A.
Yeah, correct. So simple as that. So let me think any other. I give you a vector example. Let's say 6a, make it a bit complicated. Minus a plus b. What will you get? Beware of the bracket.
The 6a must times with the negative a and the b.
Means what's your final answer?
6 negative a plus b.
Careful,
Wrong.
this one is negative, negative. What will you do?
7a plus b.
Wait. 7. This one minus and plus.
There is negative minus B.
Yeah, correct. So remember your basic operation. So negative and times negative, you get plus. Plus times minus, you get minus. Minus times plus, you get minus also.
Minus.
Yeah. And then plus times plus, of course, plus. So these are the four possibilities. You'll play a lot with this, your combination of vectors here. Means basic operations like minus and plus only. Divide and times we rarely use. Except this part, like this, you times in the negative side like that. Okay. And then two more formulas. So these two will come out in paper one usually. So this one, let's say I say Ka vector is parallel to A. Means you can imagine something like this, as an arrow like this, right? Let's say I put it as vector Ka. And then I got another arrow like this. This is vector A. Means they are parallel, means same gradient. Parallel means same gradient. So the line will be side to side each other. Like this, it will go straight like this. So the magnitude will be like this. Magnitude will equal to K times vector A. Means you get Ka. This is the understanding. So yeah, it's not nothing much, it's just theory. So yeah. Okay, this one is like this. K times. Actually, magnitude. This is magnitude, not vector. Like this, you write this magnitude. Means a constant times the magnitude of vector A. You will get the magnitude. Okay?
Yeah.
So next one, these are the two ones that they will ask in the exam. First. Then we can go to the question already. Okay, so these are the keywords you should look for when the question tells you. So the first keyword is actually non-zero and non-parallel vectors. So very fast only you can solve in the exam. Just look at the question, you make it equal to 0, then you find the variable, just like a normal linear equation like that. So the format is like this. HA equals to KB equals to 0. This is how you must list the formula. Means what, if I ask you what is H and K actually, what are they representing?
Constant.
Yeah, very good. So H and K are constant. And then A and B are what?
Vectors.
Yeah. So now you can differentiate between two of them.
Yeah.
One is constant, one is vector. So I say HA equals KB equals 0. So something like simultaneous. So what you can come out from this is HA can equal to 0 or KB can equal to 0. Because both are equal to each other. What means this one can equal to 0 directly, and this one also is equal to 0. That's how we get it. So let's say I give you an example of question. Let's say 2x minus 1a plus 3y minus 2b equals to 0. So if I ask you to find x and y, what will it be?
X and Y.
X and y. Or better, don't put like this. Let me put equal directly. Let's say I put 3x minus 3y minus 2b. So then I ask you to find a and b. When I say these two vectors are non-zero and non-parallel, so I say find the value of x and y. So you have to utilize this formula. How will you compare both sides? How?
Not sure.
Okay, now I show you. So this one like this, right? I said HA is 0, right? Means I can actually make this equals to 0. 2x minus 1 is equal to 0. Because I didn't tell at the end here equals to 0, right? Maybe that's why you're confused. Never follow exactly like this. But the question can also be like this. They don't not necessarily they must put equal to 0 here at the back. They only have to tell you either one of these keywords, non-zero or non-parallel, either one. Then you use this thing already. So you take this vector, you ignore, don't put the vector inside that A with the wavy sign, the one. So you put 2x minus 1 equals to 0 directly. So you will get 2x is 1, x is 1 over 2. That's your answer.
Oh.
Same for the other side. 3y minus 2 equals 0. 3y equals 2. Y equals 2 over 3. Done. And then you see when you realize you sub that inside, right? You will get 0, 0 in the end. Let's say I did 2 minus 2, you get 0 in the end. That's why they say it's equal to 0. What? So you have to get something inside here that is equal to 0. Means you're finding that value here. So this is how you do. This is for the one part of it. The other one is for parallel vectors. This one is non-parallel. So this one is paper 1, a few marks question, this one. Because very fast on it. So this one, this question, the keyword will go like this. A is parallel to B. So again, what is A and B actually?
0.
No, not that one. This one, generally, what's A and B?
A times B.
A and B separately, what are they? What are they called?
Vectors.
Yeah, correct. Means they're telling these two vectors are parallel to each other, in other words. So the formula is like this. Vector A equals lambda B. When they add something like lambda, what will it be?
Constant.
Yeah, correct. So other constants you need to be aware of is like alpha, beta, and then let me think anything else. Yeah, that's all actually here. And can be x, y, something like that. These are constants. Okay, so let me think. You learned variation before, right?
Yeah.
Your maths form 5 chapter 1, right? This is what they're actually trying to say, actually, how they get to this thing, this point, right? Let's say I give you like random k varies directly as y. How do you convert it? The 1k. K is dangerous. Z varies directly as y. How you convert it to equation form?
Z equals ky.
Yeah. So what you're doing here actually, how do you convert from variation to equation? What do you
Change
add?
the k.
So what is the k?
Constant.
Yeah. So this one, so the formula gets here, you see? Same, right? Z equals ky, A equals lambda B. So this is how they are doing it. So means, in other words, I can say that A varies directly as B to get to this point. So this is what they are trying to say. That's why they are what? Parallel what? Means their relationship is always constant. When something parallel, right, they will increase with a constant rate always. Just like a straight line. So it makes sense. So this is how they do it. So now we apply to a question. Let's see. Let me think. Now we want to find the constant in this case. Let's say you want to find this constant. So I say vector AB is parallel to vector CD. And then I put here given AB equals 2x minus y and CD equals, let me think of a good one, 6x minus 3y. So they ask you find the value of lambda, let's say.
Mm-hmm.
How you're going to solve? So you have to convert all this info to an equation, basically. So they say AB is parallel to vector CD, right? How will you write it? Like in an equation form.
2x minus y
Okay.
equals to 6x minus 3y.
Don't forget this one. Lambda. You must times it with lambda this side. Because I said this one is parallel, right? The formula is A equals lambda B, right?
Oh.
Means this one is your B. Your B is 6x minus 3y. Your A is 2x minus y. Means to make it equal, you have to add a constant. Lambda is the constant.
Lambda 6x minus 3y.
Yeah, you have to add it this side, the right hand side. So now they ask you find value of lambda, right? So how can you find it actually from this kind of equation?
Simplify.
How?
Like move to the other side.
Yeah, correct. So lambda will equal to 2x minus y over 6x minus 3y. Like this. This is how it will look like. Correct, isn't it? So I push this side, means dividing.
Yeah.
So how we want to find an exact value like a number, let's say 3 or 2 is, you have to factorize this thing here. 2x minus y, then 6x minus 3y is more complex than 2x minus y, right? So you have to factorize the complex one, means simplify. So how I do it is 3 bracket 2x minus y. I take out the 3 here because 3 is a factor of 6. Here. So when I get 3 bracket 2x minus y, right? I want to check back, right? I just times back inside. I get 3 times 2, 6x minus 3y. So it's the same thing here. And after you get this, what can you do?
Cut.
Yeah, cut. Whole thing will cut the dealer. Means you get finally 1 over 3. This is your lambda. Yeah? So when you're finding constant, right? This is the method you will apply. You try to find a combination where you can cut the top and bottom to get a number like this. That's how the question can come also. Yeah. So that's basically. So that's all the concepts you need to know this chapter. Let me see. Yeah. So now we can go to the question. So we learn from there how we apply it, all this. Okay. Where Ishan went? Oh my god. He joined back. Oh my god.
He joined?
He joined? Oh, he left already. Oh my god, my phone delayed. So wait. So it share screen. So now we apply to this question. You try to solve first this one. Find the OX first. How can you combine? OX is here, this way. try to get the idea
OA.
first.
OA.
Hmm.
XO.
OA
OX.
and no, you want to
OX.
find OX.
Oh, fine, OX.
Hmm.
OA and
You must think which
XA.
one can give you. See OA, right? You want to get to AX. So you see here, what can cancel off the A? You want to get OX, sorry.
AX.
Yeah, correct. So you can actually see it from the diagram directly. You see, you go this way, then you go up. Means these two ways is actually equivalent to this one way directly. And this is what they're trying to say. Because you see OA plus AX, right? You will cancel off the A. Then you get OX. Cancel, OX. So you see, they gave you the answers actually here directly. You see OA, you have the value, right? AX also you have the value. So you can find OX directly. So you just sub this one inside here. And then you sum this one inside here. Then you just
4A
plus.
plus B.
Yeah, that's all, correct. Just like that.
Oh.
So now I clear up. I show you think for BY now. So BY will be slightly more complex lah. You have to use the info from the ratio, I think. Yeah. So let's see. Now they ask BY. So you locate where's BY first.
PA.
So you want to get this one. Okay, you say BA. Wait, let me see. We have OA already. You have to draw out first because I rubbed off already, so I cannot see. And for A, and then AX is B. So now use this ratio. Can you know how to convert ratio to fraction?
2/3.
What is 2/3?
I don't know.
Hey, I show you. So 3bx. Oh my god. 3bx is 2a, right? So you copy back from here. So now we want to find something that has AB, right? I mean BX, so that we can find the BY. You see this triangle over here. This one, this one, this one. You want to do something here. And then you see another ratio here, OY and YA. I mean OA. You have to find AY also in order to find this length, this whole length here. So then we have to find this one first, BX, and then we find AY. Then we can combine to find the BY. So this is your process of thought. So now we want to find BX, let's say. So we know BX, they say the ratio is like this, right? Means BX is 2/3BA. Do you know how to get this?
The 3 move there, divide.
Yeah, correct. So BX is 2/3BA. Means in other words, I can also say that BX takes up 2 parts and AX takes up 1 part. This part, can you understand?
Yeah.
Yeah, correct, right? Because BX, you see, is longer than the AX based on the diagram.
Mm-hmm.
The total part is 3 because they said BX is 2/3 of BA. This is how you read it. Means the length of BX is 2/3 of the whole length here. Means the whole length here is 3 parts in total. Means BX is 2. Means this one will take 1. 3 minus 2 is 1.
Yeah.
So, and then the other info here, OY is 4/3 OA. So let me see. OY is 4. Yeah, I see here. OY is 4. Oh, this one got mistake. It's 3/4 actually. Cannot. This one. Follow the BM here. 3/4 OA. Means OY takes up 3 parts. And the OA takes up 4 parts.
1 part.
YA is 1 part. Correct. So From there, you can substitute. So I show here directly. Show you how we get the marks for this question. So here, right? Wait. So here we have, when you show this one, you get 1 mark. When you can combine, this one is the A1. This one here. You see OX is OA plus AX, right? You get
Yeah.
1 mark. Then your final answer is also 1 more mark. 2 marks. This one is 2 marks. I mean, this one is 1 mark. So 1 mark definitely come for your answer only. Where is that? So what I did here is, okay, so the ratio is actually very simple. So I showed you how we do the ratio. OY they gave here is 3/4 OA, right? I put here.
Yeah.
And then OA, do you know what's the value?
4A. 4A.
OA, what's the value?
4 times A.
Yeah, 4A lah. There here. Directly sub. 3/4 OA, right? So I can put the 4A inside this OA here. Because 3/4 times OA, what? So OA is 4A. So that I put here. 3/4 4A. So you get 3A. Means your OY is 3A actually. This one here. This one is 3A. This whole thing here. Means if I ask you AY will be what? I mean YA is what?
YA. 1/4.
No, wait. This one is 4A, the whole thing. OA is 4A. The OY is 3A, sorry. OY is 3A. Means YA is what?
1A.
This part.
A only. A only.
Yeah, only A. Because 3A plus A, you get 4A. This one. And then this one. You get this one. Means this one is, the 4A is basically the whole line from here to here. But I break up into 2 portions here and here. Means OY you get 3A and then this one is A. Based on this ratio here. Utilize the ratio. So you see here? So I make a conclusion here to find YA. OA equals OY plus YA, right? So you know how to write, right?
Sure.
Because you'll cut off the Y, isn't it?
Yeah.
Yeah, so you get OY is 3A, right? And then plus YA. So you get your YA is A. That's what I showed just now. So then we have to utilize another ratio also here. This one all actually they didn't show in the scheme, but you have to show it so that you don't make careless mistake. From here onwards only they show all this part here until down here. This one only. But this one all is your working steps before you can get to this part. Because you see, right, here to get AY, you need to find from here first. And then you want to get your BX, you have to find from here first. Because it's not provided on top here at all. So you have to do a lot of stuff. So from this ratio, you get to here, isn't it? So how you know how to convert from BX to BA, right? You shift the BA here. And then you shift the 3 here.
Yeah.
So you get BX or BA is 2/3. Okay? So you see your ratio of BX to BA is this one, 2:3. When fraction, right, your ratio is actually 2:3 like that. You read directly. Means like BX or BA means BX to BA ratio is 2:3. It's how it goes. So you convert from fraction to ratio. Okay? So then your BX here, isn't it? So BX is equal to -2B. So you can see from here, right? BX, let me find. Yeah, BX is -2B here. BX here. There. This whole thing is -3B. Be careful of your direction. Here, why I put negative is because it's going in the opposite direction. When
Going
you go
down.
this way, you get what? If I go this way,
Positive.
positive 3b, right? Isn't it?
Yeah.
Yeah, so you must be aware of your direction, because the negative plus positive sign can cause a lot of trouble if you're not aware. So what I did here is to get until here, okay, Adi. So you want to find by, right? So what is the root will you use?
PY. The BA.
Yeah. Plus?
Plus AY.
Yeah, correct. Then you already form a triangle here. So usually the question will make you to form 3 lengths lah. Then only you can find this vector over here. This is what you are finding now. So you take this plus this. So you complete the triangle a bit. So BA now this one actually I can do directly lah. This one I'm just breaking up the BA. So because BA is BX plus XA, right? This whole line. So you see BX is negative 2B. XA is negative B. Can see that, right?
Yeah.
So then AY, I'm going opposite direction. So that's why I put negative A. And then you will get negative 3B minus A, final answer. Okay, so 1 mark for this one, Nila. Final answer, 1 mark. And then this is the part lah. Do you notice this form? What is this form? I told earlier. OP equals lambda OX.
Yeah. K. Constant.
So what is the keyword for this question?
Keyword. It's the same.
No, not done. What type of vectors is it?
Okay. Parallel.
Yeah, parallel vectors. The form is A equals lambda B, right?
Mm-hmm.
So you can compare with this lah. It's the same form. Means the A and B, they just replace with a vector OP like this lah. They're the same thing. And you know why they are parallel? You see this diagram, wait, I rub off. This part, I don't want too many things here. Okay, so you see why they are parallel, right? OP and OX are they not on the straight line? Can you see that or not? Are they on the straight line?
Yeah.
So that's why they are parallel. That means their gradient throughout this line is the same gradient. That's why they said OP is OX. Means the gradient of OP is same as OX. Right? OX lah, that straight line. Okay. So now we'll start here. So this one, usually the question will give you 2 info here. But here they only provide you 1. OP is lambda OX. Usually the question will give you another info here. So you have to create for another line here lah. So you notice here, right? BP in PY is also parallel, right? Straight line up to down here. And they intersect at the common point P here. That's why I chose this line. BP equals KP BY. Don't use lambda again lah, because it's not the same value. So I use K, another constant lah. So you understand why I use K?
Yeah.
So now what we are going to do is actually you have to find a way to combine both of these vectors simultaneous, make them equal to each other. So how we are going to do it is BP, let's say I make it BO plus OP. Because I have the info here. BO I can find, right? Because I got this length and this length already. Means I can find BO. And then OP they gave you here. So you sub OP is lambda OX. Yeah? And then I just sub the vector of BA and AO. Because you want to get BO, right? Means you have to go this way and then this way. Complete the triangle. This large triangle here. You can see, right?
Yeah.
Okay. So BP I told on top here is KBY, right? So I put KBY equals here. Then I sub here. And then this one is your normal plus already lah. Don't make mistake here. Go here. And then finally you will get this part here. BY is actually negative 3B minus A. You already found here. Don't forget. Here. Means this vectors question, right, is related. Means what answer you got here is going to affect what you sub here. So you must be careful lah. Each question must be accurate, or else here won't be correct already. That's why you utilize the info from your previous question. From A2, you put the value for B. That's what I did here. No? So then you expand negative 3KB minus KA. And then this part, do you know how to factorize or not? From this whole equation here.
Times in?
Factorize not times in. You group the like terms. You see here, right? You got B here. And then there's a B here, so right? Means you see I factorize here like this. Negative 3 plus lambda. There's a lambda here. Lambda bracket the whole thing B. Because when I expand this, right, you see I will get negative 3B plus lambda B there. Negative 3B plus lambda B. So you make it into a bracket so that you can compare both vectors later on. Make 1 equals to 2 like that. So you see here the A also I do the same. 4 lambda minus 4. There? Here. So then you finally arrange it to an equation like this. So after this part, how will you proceed?
Make the lambda a subject.
No need, because I said compare, see, by comparison. Okay. This one. I use different color, too much same color already. See here. Vector B, right? And then here also you got a vector B, right?
Yeah.
So you can actually cut them off because the same thing. You make something left hand side equals to this, right? You see I get here negative 3K equals negative 3 plus lambda. Means B and B on two opposite sides of the equation, you need to solve it already. Because if you make these two equal, right, these two is times each other, right, you'll finally cross them off. Because you shift to the other side, while B divide B, you get 1, nothing already.
Yeah.
So here I arrange lah. I arrange the formula to get until here. Turn simultaneous lah. So you see here, got vector A, right? And then here also got vector A.
Cancel.
So you cancel off the vector A. So where did I write that? So here lah. Where is it? Let me see. This part. Negative K equals 4 lambda minus 4. Yeah? Then I get to here. So then what you're going to do is you have to find a way to sub one inside another lah, to solve it. So what I did here is I make K equals negative 4 lambda plus 4. Do you know how to get from here to here? The top one to the bottom one.
Negative 3 go there.
Yeah, you times the whole equation by negative lah, basically, isn't it? You see here, the K is positive, here is negative. Here got negative, here positive, here negative, here positive. If you times the whole equation by negative, so that you get here positive. See? You want to make your subject a positive K only, not negative K. Okay? So then I can sub 2 into the first equation lah. Because I got K also here, isn't it? Simultaneous. 2 variables. K and lambda. You want to find 2 things here, you see? You want to find finally this ratio lah, that's later on. So the first you have to find your constants lah, because ratio comes from a constant, what? So you need to find constant first. So negative 3, K is negative 4 lambda plus 4, right? Here. Equals this one lah, copy back negative 3 plus lambda. So then you expand. It's an algebra only lah. So you get your lambda is 9 over 11. And then you have to sub your lambda equals 9 over 11 into an equation. You can choose either 1 or 2 lah. This one or this one. Okay? So let's say I sub here lah. So negative 4 lambda is 9 over 11, right? That's why I put 9 over 11 here. Then plus 4. Then you get a K value. No? Yeah? K is 8 over 11. From there, right, you have to use your info. La. I said BP is KBY, right? So what's your value of K now?
The 8 over 11.
Yeah, very good. So that's how you put here. La. BP is 8 over 11 BY based on the original assumption I made. Because they asked to find BP to BY, what? So I need to use this one, not this one. OP equals lambda OX is not necessary to answer this question. It's just to form two equation with two variable. That's why we did that. So then you shift BY down here. You know this step, right? Shift it down here.
Shift BY.
BP over BY. I put the BY down here. Equals 8 over 11.
Yeah.
So your PY will be what? How will you find? Because you got BP and BY here now. So now you know what PY.
Minus 8.
11 minus 8, right? This part. You get 3. Yeah? Because you see here, right? Let me up here. This part. Because here's a bit messy. So here I said that what? BY is 11. 11 parts lah, that means 11. And then here is BP is 8, right? This part's 8. So how you want to find PY?
Minus.
Yeah, 11 minus 8, right?
Yeah.
3. There? PY is 3 over 11. Means 3 out of this 11, the whole length. That's why they want the final ratio of BP to PY, right? Means you have to modify a bit. So you get BP over PY. BP, the ratio is 8, right? On top here. So I put 8 here. And then PY is what? 3, right?
Yeah.
8 over 3. So I conclude BP to PY, sorry, forgot the dot here, is 8 to 3. That's your answer. 5 marks. Very worth it. It's a long step. So you have to do all these for 5 marks basically. From here to here to here. Okay. So yeah, this is harder level question this B. But for A and 1 and 2, I think it's okay This one is basic combination of vectors. B, this they'll up the level a bit Okay. So that one you need exercise only So now I show where the marks is. It's on 5 marks. So 5 marks. Okay, so when you make this first assumption, you already get a mark. That's why you always, when you get question, right, try writing something at least. Because you already get a mark, you see, without doing anything. That's why you try to write info that you can understand in the question. It might gain you marks, might. Okay? Wait, the laptop left. No battery. Try understanding the question first. Okay. Yeah, share back. Okay, so this one, where is it? Here. Okay, so where your marks is actually coming from. Let me see here. This one, right? I told you Just try showing something
Yeah.
in the question. It will get you a mark sometimes. And then the next one is when you can relate this one. So I always try to show what vectors you're combining. This part. You understand this part, right?
Yeah.
So that one can gain you mark also. And then later when you form a simultaneous equation like this part, 1 mark. Means you express k equals something. So that's 1 more mark. And then when you can find your k value, because this is what you're going to use later, right? 1 mark. And then top here, final answer, 1 mark. So it doesn't mean you cannot get the answer, you cannot get marks in this question. You can get maybe at least 2 to 3. Even though, let's say, this part you made careless, you don't get the final mark here. Means you can still get. If you don't show working and you still get the right answer, you don't get any mark. That's the concept. You need to have all this working. That is advanced. Okay?
Okay.
So total here is 8 marks. So what you target
Only
for this
for-
question? How many marks out of 8? What do you think you can get?
At least 5.
Okay, good. So that means here you score 3.
Yeah.
Here at least you score 2 until a certain part. Maybe until here you already get 2. Until this part, only 3 lines. You already get 2 marks. Okay, so this is 8 marks. So that one question SP I'm done already. So this one, integration. You studied this chapter or not?
Yeah, started it.
Started, finished or started?
Finished long ago, but forget already.
Need to recall a bit. Wait, let me see.
Yeah.
If you know differentiation, most likely you can master integration because it's the opposite of each other. Most likely. So, okay, so I give some tips for vectors first. How can you do well in vectors? Okay, so vectors, right? The first thing is master formula. This is your first tip. Because as you know, vectors formula won't be given. Like those magnitude stuff I told you earlier. So you need to memorize. Okay? So master formulas always. That one actually can apply to every topic, not only this topic, this first tip. So yeah. And then be careful with your direction of vector. Because if you see put the negative sign somewhere, then the whole question is gone already. Means make sure you always see where the vector is going. Let's say B to A, I give you phi A. Means A to B is what?
Negative phi A.
Yeah. This is what the question actually plays on. They'll give when you combine vectors, right? Some vector might not be in the direction you want. So you have to add a negative. Okay. So then number 3. Yeah, okay. So this one. And I told you also earlier, the vector questions are actually all interrelated actually. Like you saw just now, right? You use the info from the previous question to answer that challenging question, right? So you need to make sure your simple question don't make careless mistake. The basic one. Okay? So that's the third tip. And master your simultaneous. I think you're okay at simultaneous, right? I taught you the time.
Yeah.
Yeah. So remember your methods of substitution, elimination, those two. Okay. So next one, make sure you know how to make combination of vectors. means how you combine two vectors to form a single vector. Let's say I give you an example, AB plus CD. What's your answer? AB plus CD.
A, B, C, B,
CD.
C, D.
What's the answer?
A, B plus C, D.
AB plus CD. What's the answer?
A, B, C, D.
What do you mean by ABCD?
Because there's no same.
Yeah, you will get actually AB plus CD actually. You can't combine them. I'm just testing you, see whether you actually combine any of the letters or not. So actually when AB plus CD, you cannot do anything. It's like that only. You cannot cancel out any letter, okay? So be careful of that as well. So next tip, number 6. I told earlier this one. Always utilize all the info in the question. What I mean by info is actually like vector lah. I mean ratio, sorry. They gave ratio just now in the question, right? AP is 3/4 AB, like that. That is what you call ratio. So that includes ratio. And then let's say a vector also lah. They usually say AB equals X, right? So that is an info. So make sure you use it. So usually try using all the info. Usually you need a lot. Don't leave out any one info in the question. Make sure you highlight them and then use it in your working for the whole question lah. Usually it will make sure you have to use all. Not why they give you that info is for a reason. But okay. Then last thing. Vectors can also come in section B. Doesn't mean this one in SPM it came in section A, surprisingly. I think in what? Our trials exam school, it came in section B. Vectors. So yeah, you can choose it if you want, if you're ready with it. So I would say try choosing it. Because it's not like quite complex as integration, I would say. Integration is more complex than vectors. Because vectors is just plus minus only and your basic algebra. So if you master it, you can choose that question as one of your 3 choices. No? Make sure you get high marks, at least above 5 or 10, then good at it. Make sure you exceed the 5 range. Then above from there. What is it? Anything?
Nothing. Nothing.
Okay. So try choosing vectors in section B. Okay. So those are the tips. So that's basically it for vectors.
Okay.
So now we go to the nightmare integration. Integration, maybe I'll just brief you first. We don't go through the question yet. We just talk about the topic first. Because it's only 15 minutes. Okay, now. And now we go to integration. For all the formulas this chapter, one thing, must make sure how you know how to integrate. That's the basic thing. And then from there on you go. Let me think how to tell this. How should I tell it? Okay. So we analyze this word first. So integration, right? So if you think of integration, do you think it's as adding something or minusing something?
Minusing something.
Adding or
infinity.
minusing? Minus.
Minus.
Minus means it's differentiation.
Oh.
So this is the first thing you must not get confused lah. When you do integration, whether you add the power or minus the power. So now you're doing integration, right? It means add power. So how to remember? Let me see. Let me. Have you heard the word Integrasi Nasional or not?
Nope.
Huh?
Nope.
Okay, now let me convert it to English. If I say national integration, means integration is something like we say combine. Means we combine the nation. Means we combine the people of various races in the nation. That's why they call it integration. Means we integrate, combine. Means combine means it's from simple to complex or complex to simple.
Simple to complex.
Yeah, very good. Means they're going from something simple to complex. That's why we are adding the power. What? Add power means we like, let's say power 2 quadratic, right? Power 2 is quadratic. Means we add 1, we get power 3. Power 3 is cubic. That's why it's calling simple to complex. So this is how you remember. Integrate means add up, combine. Okay? So first thing you need to know is the inverse process of differentiation. That one I will discuss when we go to that differentiation question. I don't want to touch differentiation now. Okay, so first thing, how to integrate? I show you the formula. Ax power n dx. This is a general formula. I put a and then n. Means a and n are constants. Just like how we learn in vectors. Okay? So integrate, we use this S sign. Can you see it on the board? I don't know whether you can see or not. Can see,
Yeah, the big S.
Yeah. So this is how you write in the exam when you want to show integrate. Okay? So this integrate. Means this is an equation. So what you will get is ax n plus 1. You see, I add the power plus 1, right? And you see that n plus 1 at the top.
Yeah.
So this is why I call integrate. You add up. So then when you divide, you must divide this power. The power you added up here, right? You copy back down here. N plus 1. Divide n plus 1. Okay? And then why I add plus c? C can be a number. It can be like plus 8, plus 7, okay? So C is like, you can also call it a constant because it's a number. Constants are numbers, okay? So why I add C here, isn't it? Because this is an indefinite integral. In integration, you will find out you got two types of integrals, definite and indefinite, okay? Must remember that one, huh? So why I say indefinite integral is because you see the integration sign, right? Do you see any numbers at the bottom and top here?
Yeah.
No, right?
I know.
Yeah. That's why I call it indefinite. When definite integral, you will find out like this. Definite integral will look like this. 3 and 5. Can you see this here?
Oh, yeah.
So what we call here is actually 3 is actually the lower limit. 5 is the upper limit. Means in what? Definite integral, you have limits. Means like you're integrating from this point to this point. But indefinite, you can integrate from anywhere, from 0 to infinity, let's say. That's why they don't have any number here. And that's why you have to plus c. So now you understand. Plus c means so that we can do the indefinite integral. You know, it's the same thing as definite one. How to differentiate between two of them. So we add the plus c. Don't forget the plus c. This is a common mistake also. Because people do definite a lot of times, right? So the indefinite one, they forget to add plus c. It'll be useful, the plus c. Okay? So that's first part. And then I'll show you lah how we actually. I give you example lah better with numbers. Because like this very general, you don't know how to apply it, right? So you give an equation and see. Okay, so let's say we go integrate. Integrate 2x dx. So usually when you say integrate, right, they'll add the dx here. Means you integrate this equation with respect to x. Means you're actually integrating the x variable. Integrate x variable. So I'll show you example first lah. We do, then we try a question. Okay. So how we do this one is integrate 2x with respect to dx. So I copy back 2x. So now x is what power? If I just say 2x.
0 power.
Huh?
1.
Yeah, correct. Power 1, right? So what will it come on top here when I integrate?
+1.
Means 1 plus 1, what you get?
2.
Yeah.
Power 2.
So 2x squared. And then I divide what?
Divide 2.
Yeah, correct. And then what I add here?
Plus C.
Yeah, plus C. That's your integration. Done. And then this one you can simplify. 2x squared over 2, what you get?
1.
1. And then what? The top one you have to copy back, remember? 1x squared. 2 over 2 you cut off, right? You get 1. Then you still got something on top here, x squared. So usually when 1x squared, we write as x squared plus C only. 1 is already known. Like A means 1A, right? We don't write 1A, we write A only. Like a variable. Okay? So we try another one. Let's say I increase the power now. 3x squared plus 8x respect to dx. What will you get? This down one here.
3x.
Okay.
Power 3.
3x1 on top here.
3.
3x cube, right? Cube 3. Okay, over.
Over 3.
Yeah. Then the other side.
Plus C.
No, this part. Don't forget. I added plus 8x.
Oh, plus 8x.
Plus 8.
X.
X will come 1 down the power. Yes, power 1, remember. 8x means 8x power 1.
Yeah.
Means 8x will come here, right? 2, right?
Yeah.
Means you divide 1. 8x 2, then down.
Divide 2.
Divide 1 number.
2.
Yeah, correct. And then at the end, what you add?
Plus C.
Yeah, plus C. Done. So when you integrate, when got like 3x squared plus 2x, right? Means you integrate separately. You integrate this one first. You get 3x cubed over 3. This one. And then you integrate this also. You get this 8x squared over 2. 8x squared over 2, yeah? So you integrate separately. Don't do one shot. Separate, then you make sure you add plus C like that. So when you simplify, you get x cubed plus 4x squared plus C. This is your equation. And from there, you proceed with the value the question gives. Okay?
Okay.
So that's your first formula, no? The basic one. So now I will just show you the formulas, how the other part of the formulas. No? What the other formulas apply actually comes from this, because this is the basic integration one. And the other formulas will look like this. I integrate bracket fx plus gx dx. To look complex, right? This whole thing is an equation, right? Actually, they just represent it with the function. You learn function, right? Function we use fx, right? Or gx. So here they're showing it here, lah. Fx and gx, respecting to x, dx. So they write at the back here. So what this is equal to is this. Equals to integrate fx dx and plus minus integrate gx dx. Why do they put this plus minus sign here? For two possibilities. Why they put plus minus?
There's two.
Why?
There's two variable.
Because when you integrate this one, right, gx, sometimes when you integrate, right, you can get a negative value here. That's why they put negative. Let's say I give you an example. Integrate 2x power negative 2. What will you get? Integrate 2x power negative 2. Means you get what?
2x. Negative 1.
Yeah, correct. Over?
Negative 1.
Yeah, correct. Then what you add?
Plus c.
Yeah, correct. So your final one is negative 2 x power negative 1 plus c. So you see this negative sign here, right? Can you see this negative sign here? Negative 2x, negative 1. That's why they add a negative here. Because there's a possibility, right? This function can be this. Means you have to minus this thing. This is a negative, not always it's plus. So they give a possibility in the formula. Okay. So how you get this is actually you extend, integrate this whole thing bracket, right? Means you times this integration inside, integrate fx, dx also you have the times, times inside the whole thing. Then plus integrate times this inside here. Gx, dx. Yeah? So you expand basic like algebra, how you expand. That's how you do it. Okay. And then another formula is this one. A power n here. Let's say the equation looks like this, okay? So what we get is actually like this. Ax plus b. What will happen to the n on top here? When you
Plus
integrate.
1.
Yeah, correct. So the formula like this. Then divide what?
N plus 1.
Yeah, correct. And then this is one more step here. When you have an equation like this, right, you have to differentiate the content. So this is where you need to learn differentiation. You need to know how to differentiate ax plus b. That's why I said these chapters are interrelated. So when you differentiate ax plus b, you will get a. So differentiation looks like this. Well, let's say I give you an example. Y equals 2x plus 3. Let's say this is the equation. So differentiation is you do dy over dx. Means you differentiate this y equation with respect to x. This is what they mean by dy over dx. You always do, right, in your exercise. So when you differentiate this, right, x power 1, right, differentiate means minus 1. Means you will get 2x power 0 over 0. No, not over 0. You won't do over 0. Means you get 2x 0. When you differentiate a constant like this, right, 3, you will get 0 also. And you differentiate the whole number. So your final answer is 2 only. X power 0 is 1. Anything power 0 is 1. So you get 2. So that's why they add here A. A is your 2 actually. A is a constant. So B is like the 3. B is like your 3 here. So you can see, isn't it, the relation?
Yeah.
So this is how the formula comes. And then we stop here. Before what last equation before definite integral. So the one to confuse the one. So we introduce one more thing. Usually the question plays more on definite integral. So that's another lesson. So that one you have to know also. Okay, so the last one, equation of curve. They will draw a curve for you like that, the question. You see the question I sent you. And then they say, this is a keyword, gradient function. Whenever the question mentions gradient function, right, it means dy over dx. What happened to that? Oh,
What happened?
advertisement. Gradient function means dy over dx. Dy over dx actually represents your gradient, in other words. One way for you to understand this is y equals 2x plus 3, right? Remember your general form, y equals mx plus c? You remember this?
Which one?
So what is your gradient here if you compare these two equations? The value of your gradient.
Brother, can't see.
Wait, y equals 2x plus 3, right?
Yeah.
You compare with y equals mx plus c. So what is your m value?
2.
Yeah, correct. And then if I do it separately here, if I want to do y equals 2x plus 3, if I do dy over dx, what's my value? Dy over
2x
dx
plus
of
3.
2x plus 3.
2x over 3.
No, not integration, differentiation.
Oh.
You'll get 2. That's what I showed earlier. Because x power 1, you minus 1, right?
Yeah.
Means you get 2x power 0. Means 2 lah. So can you see the similarity? M equals 2, dy over dx equals 2. So I can say my gradient is actually dy over dx and is equivalent to 2. So this is the conclusion I come up with. There you go. Okay. This is the conclusion. Can see, right?
Yeah.
So, dy over dx, you can also call it as f prime x. So another way, if they give you a function fx, you differentiate the function, you will get f prime x. Okay. So now equation of curve, how we write it? So equation of curve, y equals integrate f prime x. Means when you go from differentiation to integration, right? You have to integrate lah. Common sense. From a lower power to a higher power, you have to integrate. That's why the equation is like this. Integrate the differentiated equation. So like from power 0, you go plus 1. Okay? So another way to write it is y equals integrate dy over dx in respect to dx. Like this. You can see the similarity there. Means from differentiation to integration, you integrate. You understand, right?
Yep.
Okay? Okay, right? So this is the formulas you have to memorize for indefinite integrals. That's all. So yeah, this basically, yeah. Okay. So yeah, that's all for today.
Okay.
Wait, penyakan. Where is this? Wait, I exit this one first. Okay. Okay. Thank you.
Okay. Bye-bye.
Bye.